Thank you for joining me, class, for the second piece of our arithmetic series notes. So today we're going to start covering something called summation notation. So we're talking about series. It's often easier, rather than writing out every single term, it's often easier to use what's called summation notation. So we're going to learn, first of all, what the summation notation is, and then how to use it to still find the summation of these arithmetic sequences. So the pieces of an of summation notation. You have your lower limit, so what your first term is. Oop, I apologize. There we go. So what our lower limit is, our upper limit. So basically that's your n values. What is the first position that you're looking at, and the final position that you're looking at, and then the explicit formula. All right, so again, the thing to know, both of these are n values. Both of those are tracking what positions in the sequence are you talking about compared to the explicit formula. So you'll even usually see that first one down there being n equals. So you're starting at n equals 1, and that's saying you're working your way up to n equals 5 using that explicit formula for the sequence. All right, so now that's what we're talking about again when we're talking about summation notation. So let's discuss, how can we write something in summation notation? Because it's going to be important that we can go back and forth between the two. So for summation notation, what you need is first find the explicit formula of the series. Okay, so easy enough. We've been doing that for a while now. Then find how many terms are in the series. And for that, you just use the explicit formula that you found. Then fill in the notation with the upper limit, which we're always going to start with 1. Upper limit, which is going to be that n that you just found. And then the explicit formula. So let's take a look. So the first thing, we need to find the explicit formula. Well, the explicit formula, again, looks like this. So, an equals, well, your first term is 7. D, well, looks like to me we're adding 4 every time. So, now since we're going to have to be using this, let's clean it up a bit. So I'm going to distribute that 4 and then subtract the 4. So our explicit formula is going to be 4n plus 3. Okay, so again, all I did, I plugged it in and then I kind of simplified that just a little bit. Now, what's the next step? Well, once we find that explicit formula, now we need to find what n is. So to find n, we're going to have to plug in that 207. All right, so I plugged in that 207 for an, and now I can figure out what n is for that. So I'm going to subtract 3 from both sides. So 207 minus 3 is 204. And now I'm going to divide by n. And I'm getting 51. All right, so I have my n. So now I have everything that I need to write this in summation notation. So summation notation. We're starting with 1. And we just found out that we're going up to 51. And with what formula? Well, with that 4n plus 3 that we found. And so that becomes our summation notation. So again, all it is learning the steps, okay? Remember, any formula that you need to be using, the formula will be given to you on the test. I just need you learning the structure of these problems. What is the strategy for solving each type of problem? So, let's look at the summation notation for this series. So, again, first thing, we're going to be using our arithmetic sequence formula to find the explicit formula. So, A1 is 500. N minus 1. And what is our D this time? Well, our D is a negative 10. We're subtracting 10 each time. Oh, and I wrote that wrong. I apologize. There should be a plus in there. All right. So I'm going to distribute that negative 10. So I'm going to have a negative 10n plus 10, because a negative 1 times a negative 10 is positive 10. So I'm going to have negative 10n plus 510. So again, so far all I've done is found my explicit formula. Now the next piece, we need to know where we're ending. So now I need to find n by plugging in that 10. So I'm plugging that 10 into the formula that I just found. All right, so I'm going to subtract that 510 from both sides. So I get negative 500 over here equals negative 10. Divide by negative 10, and you get 50. So my n is 50. There are 50 terms in this series. So, how can I write this? Well, we're starting at 1. We just found I'm working my way up to having an n of 50. There's going to be 50 terms in this. Following what pattern? Well, that sequence that I just made, that explicit formula. So again, so far this has just been practice in how to construct this summation notation, all right? So now let's take a look. Now that we know how to construct summation notation, let's look at how to use it to find the actual summation, okay? So, to find the sums of arithmetic series written in summation notation, find A1 and AN by plugging 1 and n into the explicit formula. Then use the finite arithmetic sum formula. All right. So, A1 of this series, the first term of this series, is going to be plugging 1 in. So 5 plus 3 is 8. We have 70 terms. So I need to plug 70 in to find that AN, okay? That's what the last term is going to be. The last term is going to be AN. So 5 times 70 plus 3 is going to be 353. Then in this case, how many terms are there? Well, 1 up to 70, that's going to be 70 terms, okay? So that's pretty easy to find. So now, isn't this all that I need to use that summation formula, so that Sn is n over 2 a1 plus an. So that's actually all that I need. So looking at these, it's actually really simple to calculate these, because all you have to do is plug in n of 1, then plug in n of 70. There's 70 values there, so n is 70 itself. Boom, you have all the information that you need. 70 divided by 2, a1 is 8, an is 353. 70 divided by 2 is 35. 353 plus 8, 361. Multiply those together, you get 12,635. Right, and again, that is it. Done. So, let's take a look at our next one. So let's pick out that same information. We need the first term. Again, you get that just by plugging in 1. So our first term is going to be -5. Our last term, or the 40th term, 120 minus 8 is going to be 112. And there's 40 terms here. And again, that's all you have to do to get the information that you need to plug in to our formula. So, now I need some more space, so I'm going to erase this. Hopefully you have enough space on your paper. So we use our formula. So there's 40 terms. Divided by 2, a1 was -5. an was 112. So you get 20 times 107. So you get 2,140 as your answer. So again, don't memorize formulas. Learn the process. The formulas will be given to you. All right, now to end. Even if the series is not arithmetic, you can still find the sum. You'll just have to calculate each term, and then you'll just have to actually add them up in the end. So because look at each of these. Arithmetic terms we know follow the equation of a line. So if the equation isn't the equation of a line, you can't use the arithmetic series formula to find the summation. You'll just have to plug them in. So for example, this first one, if I want that summation, doesn't follow an arithmetic sequence, so I'm just going to have to add them up. So my first term, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. And now, again, because it's not arithmetic, I can't just use the formula. So I'm actually going to have to manually add these up. So 1 plus 8 plus 27 plus 64 just gives me 100. So you can plug and chug your way through these, okay? So our next one, n minus 1 squared. So my first term is going to be 1 minus 1 squared. Well, 0 squared is 0. My next term, 2 minus 1 squared is 1 squared, which is just 1. My next term, 3 minus 1 squared is 2 squared, which is 4. 4 minus 1 squared, which is 3 squared, gives me 9. 5 minus 1 squared is 4 squared, which is 16. Again, not arithmetic, so you just have to manually add up those 5 terms, and those 5 terms give you 30. All right, and this next one kind of has a cool trick involved. I really enjoy this next one. So let's look at this series. So I plug in an n of 1. Well, negative 1 to the first power, here, and I'm actually going to erase some of this so I have some more space. Negative 1 to the first power is negative 1. Negative 1 squared. Well, when you square a negative, it becomes positive. Negative 1 to the third power. Well, any odd power still has, excuse me, will stay negative. Negative 1 to the 4, an even power, will make it positive. All right. All the way up to the 100th power, an even power. So we're going to end on an even note. All right, so let's take a look at this. Now here, you may be thinking, how am I supposed to do this? I'm not calculating 100 terms to add them all up. This is ridiculous. But there is a fun little pattern here. So look at this. Negative 1 plus 1. Actually, here, let me do this in another color. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So every one of these is pairing up. Every negative pairs with the positive. So if we're ending with that positive, it means its final thing is canceling that negative 1 that was before it. And in doing so, that means our final calculation will just be 0, because all of these are just canceling each other out, giving you 0. So again, there won't be anything near that complex on the test, but it's a fun little brain exercise to think, what's happening there? What pattern can we use? All right, so that is the end of this notes. So again, thank you so much for joining me. And come back to class with this completely filled out and ready to do your practice work.